Hello, and welcome to another edition of DDI's Productivity Webcast Series. I'll be your host, Joseph Richter, and today we're going to talk about SolidWorks certification preparation. And to help you prepare for your SolidWorks certification, I'd like to talk to you about the following. First up, the main question: why consider becoming certified? Then I'll show you which certifications are available, and I will take you through how to purchase a certification exam. Then I'll introduce you to the SolidWorks Certification Center. Then I'll talk about some of the prerequisites for taking an exam. And then I want to share with you some general certification tips. And then I'll talk a little bit about the Certified SolidWorks Associate, as well as show you a sample exam. Then we'll talk about the Certified SolidWorks Professional exam and show you a sample exam for that. Then we'll talk more about the Certified SolidWorks Professional Advanced exams, including sheet metal, weldments, mold tools, and surfacing. And then I'm going to leave you with some final thoughts on certification. Alright, first up, the main question: why consider becoming certified? Well, depending on your current situation, your answer is going to vary. For example, if you're a student, maybe you want to claim bragging rights among your peers. After all, what better way to do that than to establish yourself through taking an official SolidWorks exam to prove how good you are? Not to mention, it looks great on your resume for after you graduate. It'll help you land that first job. If you're currently unemployed, this will look great on your resume as well. After all, hiring companies are looking for SolidWorks users that understand design intent, which means they're going to build practical models that everybody can change and maintain parametric design practices. The CSWP will help provide proof that you are a competent SolidWorks user. If you're employed, at your next review, this will help to prove that you're a proficient SolidWorks user, which could lead to that ever-elusive raise and or a promotion. And one of the ways that you can help sell this is your company can use your certification status in their marketing efforts. So when they're going out to do proposals, they can brag about your proficiency and your skills, which will hopefully lead to more projects. And it's a win-win because it keeps them busy, which keeps you busy, which keeps you employed. Or if you're self-employed, then you can use it to prove that you're not going to waste your client's time on poorly constructed models or learning the software. And to sum it all up, the main bottom line is engineering firms basically need to know how well their users can generate a model. You may have noticed a trend in industry, and that is when you get a call back from a resume, a lot of times they want to bring you in for a SolidWorks test. Now, these tests are all unique to the company, but generally speaking, they're all the same in the fact that they sit you down with a part and some calipers, or maybe a drawing, and they ask you to build a model of that part. And then when you're done, you go up to them and you say, okay, I'm ready for my interview. And they look at you and they say, we'll call you. And you feel a little dumbfounded because you just spent time building the model. But basically what they want to do is they want you to leave so they can go and take a look at your model and find out how you think in SolidWorks. After all, once a company has established a team of design intent-oriented users, the last thing they want to do is invite a hack modeler into their group, because once you have design intent established, a hack modeler will very easily tear a giant hole through their data set, and it may not even be intentional. So they're trying to look out for their best interest, which is to maintain the integrity of their data. So, what certifications are available? Well, we have the Junior CSWP, also known as the Certified SolidWorks Associate. This exam is targeted specifically for college students who have not yet had experience in industry using SolidWorks. Next, we have the CSWP. The Certified SolidWorks Professional exam is the industry standard test that checks for an individual's grasp on the concept of design intent. Again, design intent is building a model that's easy to change. Then there's a few advanced CSWP exams, each with a different industry focus. First one here, the Certified SolidWorks Professional for sheet metal. This is a certification test based upon the use of the sheet metal tools in SolidWorks geared for the sheet metal industry. Then there's the CSWP Weldments exam. Like the CSWP sheet metal exam, the Weldments exam focuses on the weldment tools for use in industries that make extensive use of weldments. Then there's the CSWP surfacing exam. The focus for this test is, of course, the SolidWorks surfacing tools, typically used in consumer product design. Then there's the CSWP mold tools exam, with the main focus being on the mold tools for companies that plan on developing mold tooling. Then there's the Certified SolidWorks Simulation Professional for FEA, and this tool is based around the SolidWorks simulation tool. And finally, the Elite certification. The Certified SolidWorks Expert is a user that has passed the CSWP exam as well as a minimum of 3 of the 5 advanced certified professional exams, and then passed an even more stringent exam focusing on design intent and change. So, how do you go about purchasing a certification exam? Well, if you go to SolidWorks.com, from the support drop-down, you can click on certification. This will take you to a web page that talks about all the exams, and in the upper right-hand corner, you're going to see a link for purchasing an exam. Now, if you are current on your SolidWorks maintenance, your subscription actually entitles you to 2 free exams, which, by the way, when combined is around $120 savings. In order to gain access to these promotional codes, just click on the special promotional offer for subscription service customers. This will require you to log into your customer portal, but once you do so, it'll take you to a page that gives you these coupon codes. So the first code is good for one CSWP or CSWA exam. Then the second code is good for one of the advanced exams, be it sheet metal, weldment, surfacing, mold tools, or the FEA exam. So let's go to SolidWorks.com and I'll show you how to do this. Okay, so from SolidWorks.com, if you hit the support drop-down, you can click on certification. This takes you over to the certification page where it lists out all of the certification exams. Now, to purchase an exam, you could click on Visit the Online Store, or as I mentioned, if you look in the upper right-hand corner here, we can purchase a certification exam. When you click on that, it takes you to the store. All right, if I wanted to buy the associate exam, I could add that to the cart. But what I'm interested in here is the Certified SolidWorks Professional. Now, it is required that you purchased all 3 segments. Okay, so I'm going to add all 3 of those to the cart. And by the way, you don't have to take these in the order of segment 1, 2, and 3. Doesn't really matter. The point is you have to pass all 3 segments in order to get your certification. When you click on Checkout, you simply fill out your information here and purchase. Now, if you look here in the middle, it's asking if you have a coupon or promotional code. If so, enter it here. Now, I did mention that if you're on subscription with your SolidWorks software, then that entitles you to a free exam. So the way that this works, first off, if you take a look in the upper right-hand corner here, it does say CSWP offer for subscription customers. Well, when you click on that, it's going to ask you to log in to the SolidWorks customer portal. Once you do that, let me log in real quick. And once you're logged in, you can find certification under community. And now when you click on that CSWP offer for subscription customers, it'll give you the coupon codes. And then from here, all you need to do is jot down these codes and then use it when you go to purchase your exam. Then when I go to purchase my exam, and I go to checkout, I can apply the coupon code here, and it zeroes it out for me. Then you would return here and do that for the other exams, be it sheet metal weldment, surfacing, mold tools, FEA, etc. And keeping in mind you can get one of those other exams for free. And with that, let's get back to the slideshow. So now you have credits to take the exam. Next, I want to introduce you to the SolidWorks Certification Center. This is basically the website where you'll go to download and take the test from. It's also the main website where you can log in to view your certificates, and then you can also print them out on cardstock. You can also go through your past exam results, see how well you did. You can also manage your test credits from here, which, by the way, you can purchase multiple test credits and then generate vouchers to issue to other users. So, for example, a company could buy 20 credits and then issue vouchers out to 20 different users among the organization. It's from this same login that you can decide if you want to be listed in the online directory for certified users. And since there's an online directory, this also means that you can find certified users in your area, at least those that have chosen to be visible for the online directory. Or finally, another important aspect of this SolidWorks Certification Center is you have the chance to validate a certificate that somebody might have put on their resume. You see, each certificate carries with it a certificate number, and that number is unique to that user for that certificate. And let me go ahead and show you how to do this. So to get over to the SolidWorks Certification Center, we're at solidworks.com from the support drop-down under certification. Over here on the left-hand side for certification and all the exams, at the bottom here it says certification directory. If you click on this, it'll take us over to the SolidWorks Certification Center, and it is from here where you will download your test, and then you'll pick your application language. Then it will ask you to either generate a virtual tester user ID, or you can say I already have one. Then you input your information, and then you continue. And then from here, based on the credits that you have, you specify the exam to start. So for example, if I'm looking at SolidWorks Certified Professional, there's segment 1, 2, and 3. And you just basically click on this to start the exam. It asks you to pick which language. The reason this is a little truncated is because I'm zoomed in, but you pick your language and then you click on Start Exam, and then you hit OK. And then you click on Start Examination. To see any more, you're going to have to start your own test. Alright, once you've taken the test and you've earned your certificate, the way that you go to print them out is you go ahead and log in, and then from that account you can see the certificates that have been earned, and then in order to print them out you click on the PDF symbol here, and then it brings up your certificate. And I mentioned that each certificate has its own unique ID. This number, if you were to go to verify it, will show you this certificate. To see your past results on older exams, just hit back and then go over to the Exam Results tab. And here you can see the exam and what percentage was answered correctly based on the area for that test, both pass and fail. It also tells you how long you were in the test. And you can scroll through all the tests that have ever been taken on this account. And then you can manage your credits from here. So here I can see the Certified Associate, 19 credits. And then to give a credit to somebody, you just create a voucher. You can specify when the voucher expires and whether or not you want to track it. And then to decide if you're to be listed in the online directory, if you click on your settings in the lower right-hand corner here, it brings up the settings for this account and list in online directory, yes, and then update. And then to find other certified users in your area, just click under Certified Users and then pick out which certificate you want to find out about, and then select a country and then a state. So if I take a look at Arizona, I'm going to find out that there is currently 107 users in Arizona, but only 54 have chosen to be visible in the directory. And so here I can see the people that are certified in Arizona, and you can sort it by the company, last name, etc. And a few people that I do want to point out. First off, Gerald Lacey. Okay, Gerald Lacey is over at Mesa Community College. He's an instructor there, and you can see that he has his CSWP that he got on November 28th, 2009, as well as the sheet metal, mold tools, and weldments certified professional certificates. And then another one I want to point out here is Perry Wood. Perry is an instructor over at Northern Arizona University in Flagstaff. And then finally, if you get a certificate, or rather, if you find out about a certificate ID, you can check to see if it's real. So for example, let me enter one in here. You can verify that a certificate is real. And with that, let's get back to the slideshow. Okay, so now we're going to go ahead and talk about the prerequisites for taking the test. And these I pulled from the certification area under frequently asked questions. The first requirement is internet. Question number 3 on the FAQ was, do I need an internet connection to take the certification exams? And the answer is yes. So you need to be connected to the internet. There's no standalone test available. The next question that I felt was applicable to mention here is, it's recommended that you have a second computer to take the test from. In other words, you want to have a computer that can access the internet, and then you want to have a SolidWorks workstation. The reason for this is, as you're taking a look at the test and the images to show you the parts that you have to draw, flipping between that and SolidWorks will be very time consuming. So at very least you want to have dual monitors if you don't have access to a second computer. But as question 11 points out, will my answers be lost if my computer crashes? Will I lose my testing credit or have to pay again if my computer crashes? And the answer to this is yes. You'll have to start the exam over and no refund will be issued. Once you click Take Exam, your credit is used and therefore they will not refund your payment. So if your computer crashes, your answers are not recoverable. So it is highly recommended that you have a second computer to take the exam from. In other words, you want to have a SolidWorks workstation to do all the heavy-duty lifting on, and then you want to have a secondary computer that can connect to the internet that you can type your answers into. So worst case scenario, if you have to reboot because you run out of RAM while you're running SolidWorks, it's not going to hurt the test other than the time it takes you to reboot. But at least you'll have the ability to pick up where you left off. And then another requirement here, what SolidWorks version is required for the CSWP exam? The answer here is SolidWorks 2008 or newer. Now, one thing I did want to point out here is SolidWorks 2009 Service Pack 4 or newer is actually required for the Advanced Weldment Specialist exam, simply because of some of the corner treatment trims that are required on the test. Those corner treatments were actually new in SolidWorks 2009, so that would be the one test that you want to be on a newer system than 2008. Now, if you're talking about Student Edition is always 1 year behind commercial, so you're going to need Student Edition 2009 or higher to take the CSWA. Okay, let's go over some general certification tips. The following advice is a compilation of tips and tricks that I've been able to pull together from all the applications engineers here at Digital Dimensions, as well as some input from Perry Wood and Gerald Lacey. And the first thing to point out is the objective of the certifications. The main goal of SolidWorks certification tests are to test your mastery of design intent. Again, design intent is the plan on how the model or the part is going to change during its design cycle. So the better we are at predicting how the part should change or will change is obviously going to make that part easier to use. So before the certification tests, the number one piece of advice is practice your modeling speed. That is important because you don't want to feel rushed on the exam. Now, aside from practicing your modeling speed, the other thing you want to pay attention to is how fast you can take a look at a part and decide how you should start to model it. After all, you want to be good at that part of it too, because even if you're a fast modeler, if you take a look at a part and you can't break it down into the basic shapes to get you started, then no matter how fast you are, if you pause and you take a long time figuring out how you're going to build that model, then that's going to cost you time, and there's not a lot of extra time on the exams. Alright, after you've got your speed down, both with respect to figuring out how you're going to model parts and just in general speed with SolidWorks, some preparation would be to generate some generic part templates for the test. After all, you don't necessarily want to use your company templates on the exam. These generic templates should be stripped down. They should have units of inch and millimeters, probably with their precision set to 2 decimal places or what have you, and they should all be mapped under tools options for file locations for document templates. You should also set a folder aside for use during the test, and while you're taking the test you're going to be downloading some files to use, in which case you would want to throw those in the folder, especially if you're using 2 computers here. You want to make sure you either have a network folder shared between those 2 computers or a thumb drive or something that you can transfer the files from the internet computer to your SolidWorks workstation. As well as you'll need a folder to save your work during the test. Now while you're taking the test, here's the advice that we've prepared for you. First off, you might want to scroll through the exam and take a look at every single question. Therefore you can formulate a modeling plan based on the changes that you see are going to happen to that part. And once you develop your modeling strategy, you want to stick with it because you don't have time to second guess yourself and start over. That's why you want to look at all the questions, see what changes are going to happen, and then plan out how you should build that part. And then as you're going through your questions, taking a look, figuring out how you want to approach it, at this time would be a good time to download all the required test parts. Now, with respect to how you should be modeling your parts, well, generally speaking, you should make your model from a datum structure, specifically planning out the location of origin. The way that the online tester grades you is based on typically the center of mass and or the mass of the part. Now, during the test, they're going to make changes to values. They give them labels like A, B, C, and D, etc. And for these values, I would highly recommend using link values on those common variables that are going to change throughout the test. A couple of reasons to do this. Number one, you might have A in multiple locations, or the second reason to do this is in the tree, once you've added a link values item, the equations folder now shows up in the tree. And when you hit the plus sign for the equations folder, you're going to see all of your linked value groups. That's a very quick way to double check the variable A when it's changed to what the current value is. So if you have A, B, C, and D all showing up in the tree, just at a quick glance you can see if you've updated it to the correct value. Also, when you're taking the test, don't forget about the SolidWorks help if you get stuck. While you're building your models for the test, pay attention to the units being requested, the precision or decimal places for your answers, and pay attention to the material or the mass properties requested in each question. It's also best practice to save as a new copy for every single part, naming it based on the question. That way, while you're going through the exam, if you notice a mistake, maybe you missed a fillet or something that has technically been there all along, by saving as each question number, you'll be able to go back 3 questions prior to open the older file and add the missing fillet and update your answers. After all, if you fail to do this and you're sticking with one single model and progressively changing it without making backups based on each question, then you're going to have a hard time rolling back through all the 2 or 3 questions worth of changes to get back to step number 1 where that fillet was initially missing. And again, there's not a lot of extra time for doing that. So you want to save as a new copy for each part for every question. As you're speeding through the test, if you find yourself at the end of this test and you have some extra time, I would start over and review each question as well as your answers, double checking for simple things like precision, decimal place, and mass to make sure you're not going to miss that question based on a simple mistake like that, or go back to the questions that you were not comfortable with or 100% sure on and redo those. Also, when you're going through the test, make sure you understand what that part looks like. Take the time to look at every single picture that is provided for each question and quickly identify the one that will help you get started. Most of my advice has been about time, so you're going to want to keep an eye on the clock, time management. When you're running out of time, take a quick look at the summary to determine how much each question is worth and do the highest valued questions next. So that way if you run out of time, then you might miss the lower point questions. A good example might be while you're taking the exam, if there's a simulation express question for stress analysis and you're taking the CSWP, that stress analysis question might only be worth 5 points, whereas there might be a modeling question that's worth 20 points, and if you spend half of your time on the 5-point question, then you're going to fail the test. So know when to skip a question, move on, and then as you have completed all the modeling challenges, go back and re-review that simulation question. And then just as a general best practice, you always want to use fully defined sketches. When building an assembly, pay attention to what order you mate parts together. In the case of 2 plates and a pin, you'd want to mate between the holes on the plates, bore to bore, then add the mate to the pin very last. And also, I would highly recommend fully defining all of your components in your assembly. Therefore, everything is fully located for predictable results. Keeping in mind with your assemblies the location of origin for the first part, because a lot of times they will give you a starting origin and they will want the center of mass for the assembly. One other piece of advice would be if you mess up the initial origin on the first part, as long as you're familiar with generating coordinate systems, then you're probably going to be able to make a new coordinate system at the location that they wanted the original origin, and then you can do your mass properties from your created coordinate system. So coordinate systems would be important. And with that, let's take a look at the Certified Associate exam. The Certified SolidWorks Associate. This is the junior level CSWP exam targeted for college students who do not yet have real-world experience with SolidWorks in industry. Now, when preparing for a certification exam, nothing is better than a good training course with a great instructor. So my training recommendations for the CSWA are college courses such as the following. At Northern Arizona University in Flagstaff, Arizona, the course is ME 180, Introduction to Engineering Graphics, with the instructor Perry Wood. Or at Mesa Community College in Mesa, Arizona, the course there is GTC 266, Solid Modeling with SolidWorks, and the instructor is Gerald Lacey. Both of these teachers are certified SolidWorks professionals, so they have a real-world grasp on design intent, and they're going to be able to share with you the secrets to mastering parametric design with SolidWorks. Now, if you're not in Flagstaff or Mesa, if you can find an equivalent college course in your area that focuses on design intent using SolidWorks, then I would recommend them as well. It wouldn't be a bad idea to check out the CSWP directory in your area to see if there are any schools listed on there, in which case you're going to find instructors that also carry this certification. Or in lieu of a college course, I would mention Digital Dimensions SolidWorks Essentials course, and we have locations in Phoenix, San Diego, Tucson, Fresno, and Sacramento. My webcast recommendations when preparing for the Certified SolidWorks Associate include design planning and communication using SolidWorks. And then for practice modeling, I would recommend completing the CSWA sample exam. Now for the webcasts, if you go to our website, ddicad.com, in fact, let me take you over there. So from our website, ddicad.com, if you go to the training drop-down, you can click on webcasts. From here, you can do a keyword search for design planning or for communication. And you will find the two webcasts I recommend for the CSWA. Now for the sample CSWA exam, if you go to solidworks.com, again from the support drop-down under certification, when you click on the CSWA, under the quick links in the upper right-hand corner, there is a sample exam. You can click on that and download the PDF along with the sample files. And here you want to take a look at what the exam is going to be looking for. So hands-on challenge in the following areas. And with that, I have an older sample exam to share with you. So let me take you over into SolidWorks. And in order to build this part, you're going to download the PDF that looks something like this. And on the PDF, it tells you what units to build the part in, what precision to build it in, and it tells you where to place the origin. And then here are the variables that will change throughout the test, A, B, and C. And then it's telling you that all the holes are through holes, as well as providing the material and the density. And then of course it gives you a 3-view drawing. And by the way, while you're building this model, this is why it's crucial that you have a secondary monitor to build your parts from, or a second computer if you have that available to you. And then as you scroll down here, you can see the drawing, and here's dimensions A, B, and C, the ones that will change question to question on the professional exam. I know we're talking about the associate, but in the professional exam, we use the same data set over and over again. After all, it's about tracking changes. So to answer this first question, it's asking you for the overall mass of the part in grams. Now, one of the things I want to point out here is the dimensions and how they're laid out on this model. Okay, this is how your dimensions should look on your own model to match what they're asking for. So as I go back to SolidWorks, okay, you can see that my dimensions come from the same datums that their dimensions did. For example, the 12 comes from the back edge. It's not 50 minus 12 coming from the front face. So let me go ahead and roll back here and show you how I built this model. You can see that all of these are cuts, and my very first feature is a stock feature, my first extrude, and here you can see dimension A, B, and C. They are clearly labeled. That's because when I made the dimension, I typed in dim A, so that shows up. Also, you'll notice the red chain link symbol here. Basically, when you double click on a dimension, you can hit the drop down here and link value. So let me unlink it here and then show relinking it. And then when you go to link value, you can type in your shared values group name. In this case, I'm going to relink it to dim A. And the reason you would want to do something like this is because under the equations folder in the tree, your global variables are shown. So here are my link values for dim A, dim B, and dim C. Therefore, when I go to my next question and those variables change, I'll be able to check very quickly at a glance at the tree to make sure that I've updated those variables to the correct value. Keep in mind this trick also works on your day-to-day designs. If there's an important dimension that you need to track in your design, even if it's only being used in one place, I would highly recommend adding a link value to it so that way you can call attention to it here in the tree. Okay, and as I roll through the rest of the model, you can see how the cuts are added to the initial stock to generate the final part. Again, all of my dimensions are coming from the same datum structure that was outlined on the drawing, so there's no guesswork here. A model like this is much easier to change than a model with only 3 features and super complicated sketches. For this question, they were asking for the mass of the part, so you would go to Evaluate, Mass Properties. Now, if I wanted that mass properties to show up on screen here, I could go to the File Properties, and from here, add a property, maybe something like weight, and then you can link that to the mass of the part. Once you've done that, it's just a simple matter of adding in a note and then with that note linking to the property. So here I can see the weight. And they were asking for 2 decimal places, so I would want to make sure that my units match. So units of 2. And then when you go back to the PDF, I can see that my dimension matches B. Being the certified SolidWorks associate, they have some multiple choice questions on the exam. Now for the professional, you would have taken that same part model and made a couple of changes to it, which is the reason that you'd want to call attention to dimension A, B, and C, the ones that are going to constantly change. Here for multiple choice, they have a few sample questions asking about Cosmos Express. What can you do with regard to the mesh settings? And here, a fine mesh setting cannot be applied to a specific face. It must be applied to the entire model, so that one would be C. Question number 3 here, it's asking about creating a drawing view, and they are showing here a broken out section. And then you go down to question 4 here. Alright, on question 4, you have to model the brackets and the pins and assemble them in an assembly. So they give you all the dimensions in order to do this, as well as the gap between the brackets. So back over here in SolidWorks, I'm going to go and open that assembly. And basically each part has been modeled according to the dimensions that were on that other drawing, as well as mated. Here you can see the angle mates to position everything where it should be. And here in the tree you can see that there are no minus symbols, which means everything is fully defined. And then to find the center of mass, you click on Mass Properties, and of course it gives you the center of mass. And just like with the mass note, you could have a center of mass note here. If you go to File Properties, and then Center of Mass, when you hit the drop down you'll find center of mass for X, Y, and Z. What you want to do is take center mass for X, copy that, and then swap out that variable for Y and Z as you paste it, because if you hit the drop down again, it's just going to replace what's already there. Okay, and in fact, I have a note here to point out the center of mass. Again, this is just another trick to save time. Back over to the PDF to hit the last assembly. So as I scroll down here, I mentioned they were asking for the center of mass. Alright, and then the last one here. Again, it wants you to model all these parts and position them based on the assembly. So one of the things I like about the Certified Associate Sample exams is they have you do a lot of modeling. Okay, and the Certified Professional Sample exams, they have you build one model and constantly change it, which is also good, but the Certified Associate gets you in the practice of making a bunch of models. So here's the assembly and all the parts. Let's go back over to SolidWorks, take a quick look at that. So my next assembly is here. Again, each part has been modeled based on the dimensions found on that other drawing. Okay, and with each one, as you roll through, using the stock method, creating your cuts, adding fillets, and mirroring when it makes sense, and then locating this clamp with a distance mate, that one being this one here, from the front, and then there's your center of mass. This is why the location of origin is so important. If you didn't locate the origin where they asked you to, then your center of mass is going to be all wrong. If your origin was not located where they asked you to put it, you could always insert from reference geometry a new coordinate system, okay, and locate it where they would want it. And then when you go to do your mass properties, you can specify your output coordinate system as being based upon the coordinate system you just generated, which in turn changes your center of mass. And with that, let's take a quick look at the last part for this associate sample. So as I scroll down here, there's one more part, again, giving me the material, the density, what units to use, the decimal places, and where to place the part origin if necessary, and then the changing variable of A that they happen to be using in a couple spots. and they're asking for the overall mass of the part in grams. So let's go ahead and open that one. Here again, as I roll back, start with your stock, and in this case, build a couple pieces of stock. Okay, the reason that that cut is before my next piece of stock is because I want to open a sketch on that face there to generate the next piece of stock, and then the cut can go up to surface. Keep in mind all your intelligent end conditions. The more that you can utilize your intelligent end conditions, then the less manual work you have to do. Okay, so up to surface on that there. And then as you roll through here, you can see the final cuts being added here. And then a plane thrown in here to add a boss extrude with a cut. And then with this one, they were asking for the mass of the part, so you can go to Evaluate and Mass Properties and see how much it weighs, provided you have the correct material. And as I flip back to the exam, it does give you the answers at the bottom, so you can double check your work. And with that, let's get back to the slideshow. The Certified SolidWorks Professional, Core Solid Modeling Specialist. This is the primary certification for all industries. My training recommendations are from Digital Dimensions, take the SolidWorks Essentials class and the SolidWorks Advanced class, which encompasses the advanced part modeling and assembly modeling courses. My webcast recommendation for the CSWP are the Design Planning webcast, the Communication Using SolidWorks webcast, as well as the Building Efficient Assemblies webcast. And for practice modeling, I would recommend completing the CSWA Sample exam, as well as the CSWP Sample exam. And for extra study, I would review your SolidWorks Essentials, Advanced Part Modeling, and Advanced Assembly Modeling books, concentrating on the topics listed at SolidWorks.com under the certification area when you click on the CSWP. And then for just some extra tips, I would highly recommend avoiding sketch fillets, as is a best practice anyway. We recommend avoiding sketch fillets, except in the case of a profile, path, or guide curve for sweeps and lofts. Also, you want to be comfortable mating between planes of your parts, especially as it relates to fully defining your assemblies. This includes clocking your parts like fasteners. And you should also be comfortable using and creating coordinate systems and reading mass properties. And while you're reviewing your SolidWorks Essentials, Advanced Part Modeling, and Assembly Modeling books, I would remind you that you can download the files that you used during your training class from SolidWorks.com. So let's go over to SolidWorks.com to take a quick look at some of these links. From SolidWorks.com, the certification area, if you click on CSWP, it's going to show you the areas of interest for each segment of the exam. Okay, as well as other general topics that'll be covered in the exam. I would point out the sample exam can be downloaded here, okay, and if you want to download the files that you used in your Essentials and Advanced courses, if you go to that same support drop-down, you can click on Training, and then from the Training area, you can click on Training Files, and this is where you can download your SolidWorks training files. And with that, I have a sample CSWP exam that I want to share with you. Okay, so here I have open the CSWP sample exam from 2008, and here you can see the part that needs to be modeled along with the changing variables. So here's A, B, C, and D. That's the thickness of the part as indicated here, over here, and up top. And as you scroll down here, it tells you the units that the part needs to be modeled in, as well as the precision. Tells you that you can place the origin wherever you like, and gives you the material and the density, and mentioning that the part has been shelled out. And at question number 1, A is equal to 60, B will be 64, C is 140, and D, the thickness, is 19. And then on question 2, you're supposed to be able to change those variables and figure out how much the part weighs. Now, as I made mention, you'd probably want to scroll through the entire exam before getting started. So as I roll down, I can see what else happens to the part. So here it's the same base part. Looks like they removed the shell and they added a few new features, but the same variables are going to change: A, B, C, and my thickness of D. In fact, they added a new variable of E that's likely to change. In fact, they're using E here and there. And then question 3, they roll the numbers. In question 4, they change the numbers. Okay, so you can see that the exam is very practical in the fact that it's going to take you through a standard design cycle of having a part with a concept, making changes, and then here we see the concept evolving, adding additional changes, and still updating the values to the new design requirements. And then I'm going to scroll through, and here they give you the answers. So let me take us over into SolidWorks to show this model, and let me zip up to the top here again. So that's what the part should look like. So back over here in SolidWorks, I'm going to go ahead and open my 2008 sample. And just like before, I mentioned you can click on a dimension and add a note as well as a link value. Now, the other thing that I would point out is the reason I can see all my dimensions here is when you right-click on the annotations folder, you can specify show feature dimensions, and that's what makes them show up. Okay, and I can see what the mass of the part is here through that note that we linked before. And so if I was taking the exam, I would save this as question 1, and then when I go to question 2, I do File, Save As, and save it as sample exam number 2, and then update my dimensions A, B, C, and D, and move forward. Therefore, if I hadn't noticed the shell initially, I would have question 1 and question 2 parts saved out that I could open each one and add the shell feature to it, have the mass updated, and then adjust my file. So let's go ahead and take a look at question number 2. Alright, so the variables have been updated, dimension A, B, C, and D. Labeling these and being able to check the equations folder because of the link values makes this part of it very quick. And then as we take a look at the next one, question 3. And in fact, I'm going to roll through this third one after all there was not too many features on the other one. So here, the way that the model was built, as I roll back, did a thin extrude, fairly simple sketch because it's just a few lines, taking advantage of the thin feature. So as you edit feature here, you can see that it was a thin feature, and that 19 dimension is my thickness variable. And as we roll through here, you can see the holes being added, as well as the slot, and then the boss being built on the end there. Very much the manufacturing approach. And again, keeping in mind the link values, so I can double check dimension A, B, C, and D, and the newly added dimension E when I go to Save As for question number 4. All the meanwhile having my mass updated for me through that special file property that's linked. And with that, let's go ahead and get back to the slideshow. Warning! This is a sample exam spoiler warning. If you've not had a chance to attempt the sample exams for both the CSWA and the CSWP, please pause this presentation and attempt them for yourself. The samples that I've shared with you already are older samples that are no longer available on the SolidWorks website. However, the samples I'm about to share with you are the ones that are currently available on the website. So please stop this presentation if you haven't had a chance to try them yourself, and then go ahead and come on back and pick this presentation up from here when I demonstrate the current sample exams. Thank you. Okay, so from this point on, you've been warned that the following samples are the ones that are now currently available up on SolidWorks.com. So without further ado, I'm going to go straight into the current CSWA sample exam. And I'll open the PDF first. Okay, Now as I roll through here, you can see that there's some recommendations up here. And as I scroll down here, they're mentioning that you should have a dual monitor. That's recommended but not necessary. And here I'm recommending second computer. Okay, one to run internet from with a tester, and then a workstation to run SolidWorks from. So as I scroll down here, again the CSWA has some multiple choice questions on it. And now we get to the modeling part to answer questions 3 and 4. They give you basic views of the drawing, and you can see the variables that are going to change. Dimension A, B, and C. And then as you scroll down here, they give you the units, the decimal place, where to put origin, and the values for A, B, and C. And they're asking what the mass of the part will be. And looking ahead, I can see the new values for A, B, and C. And as I scroll forward, I get to see the changes that will happen to the model. So it looks like they're adding a few more cuts. It's always a good idea to look at all the changes that are going to happen to your part during the test. Alright, and then as I roll forward, I can see another pocket being added to the part. Okay, by looking at all the changes that will happen, this will help you to formulate a strategy for the test. Okay, then they go straight into a different assembly. So back up here, I'm going to take us into SolidWorks and we'll review some of this. And so here you can see the part. Again, if I wanted to see the dimensions, I could right click on annotations and show feature dimensions. Again, here's dimension A, B, and C. I can also see their values from the equations drop down. And there's my note that's calculating the mass for me. So then when I go to do question number 4, I'm going to do File, Save As number 4, and then update the numbers. So let's take a look at how it changes. So here I have the updated values for A, B, and C. My mass is updated. Again, I could verify the dimensions. And if I roll through here, I can see how the model was built. So here we have the stock or manufacturing approach. And as you roll through here, you can see the cuts were added. Alright, and in fact, as I roll through here, you can see that this chamfer has been named based on the size. You can rename your features through slow double click or selecting it and hit F2 on the keyboard. This makes it very fast when I'm checking the model. If I need to adjust one of those chamfers, I'll know which one to change. Same thing with the fillets. I like naming them based on their size. Then I add the last cut there. And then as we take a look at the next file where more changes happen, here some additional cuts were added. So let me roll back. Here's where the part was, keeping in mind that the dimensions were changed for dim A, B, and C. I'm going to go ahead and show the dimensions really quick. These dimensions, again, I can't impress upon you enough that these dimensions are being dimensioned from the same edges as the drawing that was given to me. So you want to keep that in mind, because if you have to do math, then you have to remember the fact that you are doing math to arrive at your numbers. So it is a best practice to plan out your model from a given datum structure. The additional cuts were added here, okay, to add that gap in there. Punch a hole through those two tabs there. Add another cut there, and then finish off the part with another cut there. Again, you'd want to do File, Save As, the next part number, or the next question name rather, to make your final changes. As I roll back here, okay, the last two features were cuts. So one cut here was done with an offset, as well as an intelligent end condition of offset from surface. Now, if you wanted to get tricky, you could take this dimension here add a link value group of thickness, and then tie it to this other one dimension. So that way when one changes, the other updates. Okay, and as we take a look at the last cut extrude, that too has a 1-inch offset that I could also tie in there. So again, link values is just a special equation that said these items shall remain equal. Okay, and here I can see the new mass of the part. One thing that I do want to mention, pay attention to the material when you go from question to question. Sometimes they will change the material on you, so just be mindful of that. And then as we take a look at the next question, the next one is actually going to be the assembly. So let's review the PDF on this one. Okay, so here they're showing us what the assembly is going to be, and they've provided the parts for us this time, and they're showing us where to place origin, and then they're giving us angles of A, B, C that are going to change from question to question. And for question 7, here are the variables for A, B, and C, and they want to know the center of mass. This is important to remember where they place the original origin, again, because your center of mass is going to be based upon that. Alright, so A, 25, B, 125, and C, 130. Let's go ahead and take a look at my assembly. And just like in the part file, you can add link values here to your assembly. You'll notice that there are no minus symbols in the tree, which means everything is fully defined. And here are my angle values. So there's 130 with a link value on it. There's 25 with the link value on it. And 25 with the link value on it. And that provides me with my center of mass. I would do the same thing for the next question. So file save as, assembly number 8. Update my variables. I can double check. There's 30, 115, 135. And as I compare with the PDF, I can see that is in fact what the new variables will be. And again, it's asking for the center of mass in the assembly. Again, as you scroll down, it gives you the answers as well as some hints. And here, one of the hints that I gave earlier was don't forget about help. Here they're pointing at the fact that you should remember that help is there. And then hint number 3, they are telling you where to find the test client, which we already talked about earlier. And that concludes the CSWA sample exam. Now let's go ahead and take a look at the CSWP sample exam. So from here, I'm going to take a look at the current CSWP sample. Okay, so as I scroll down here, here's the part with the variables that are going to change. I can see X and E, Y and E, and here's A, B, and C on 2 sides. Scroll through, pay attention to the details on the part. So on question 1, here are the variables, and here are the hints. They're talking about link values, and they're asking for the mass of the part. And then you should scroll down on question 2. Here are the new variables. Again, asking for the mass of the part. Question 3, the unit system, decimal places, material. Here are the new variables. And then, again, looking for the mass of the part. The next stage of the test, they make some additional changes to the part by adding a pocket in the back here and a cut revolve there. Okay. And then they update the variables again. Again, you want to pay attention to the material and the density. Looking for the mass of the part. Scroll down. Again, updating the variables. And then here are the answers. Here's this hint again. Use link values or shared values to manage your dimensions, and then label your dimensions so you can visually keep track of which ones need to be changed. Alright, so let's go over into SolidWorks and show some of this. So let me go ahead and open the first CSWP sample. And again, everything is well labeled. You can see under the equations folder all my variables. I'm going to go ahead and roll through the model first thing this time. Again, I'm using the manufacturing approach. Dimension A and B having been labeled. A thin extrude, uniform wall thickness, a boss extrude. Now, one thing I would point out about this boss extrude is, as I keep mentioning modeling from a datum structure, my sketch is on the bottom of this face here, so that way when the extrusion happens, that 35 is coming from my datum. Okay, if I'm opening a sketch on the top of this face here and saying, well, if that first step was 25, then this last step should be 10, that means I'm doing math. And if I'm doing math, it doesn't match my print, which means if this 35 dimension changes, I'm going to have to remember that this 10 dimension here is end result of this 25 plus change. After all, that 25 might change later too. So these are the things that you want to consider when planning the design intent for your model. Okay, so that's an example of modeling from your datum structure. Alright, and here we have a boss extrude. Now, one of the other things you might keep in mind, when you're doing your extrusions, you can offset your starting location from your sketch plane. Again, it's all about taking advantage of the intelligence of your beginning and end conditions for your extrudes. Okay, maybe adding another boss extrude and a cut, maybe patterning the cut, adding a chamfer, some fillets, adding the next pocket with some fillets, and then the hole wizard. Now again, if you want to visually keep track of this fillet, you could name it based on the size, R13. So if it needs to get changed, you know right where to go to pick up the 13 millimeter fillet. Same thing with this fillet here, maybe based on its size, R15. And then from here, let's go ahead and take a look at the next question. So again, you do File, Save As, Question 2, and update the variables to what the test is now asking for. And by the way, if you had established that mass note up front, of course it updates. Want to pay attention to the material, make sure they didn't change it on you. And then as we look at yet question 3, same thing, update the variables, A, B, C, D, and E. And then when you start to modify the part on question 4, it's just a matter of updating the variables and adding the new features. So a cut revolve there and a pocket there. And then finally, to see the last question with the final changes to dimensions A, B, C, D, and E, again with the cutout and the pocket in the back. And with that, let's get back to the slideshow. The Certified SolidWorks Professional Advanced Sheet Metal Specialist Exam. My training recommendations for getting ready for that exam is sheet metal weldments from DDI. For practice modeling, you should complete the CSWP Sheet Metal Sample exam. And for study, you should review your sheet metal book, concentrating on the topics listed at SolidWorks.com from the support drop-down under certification and the topics listed for the CSWP sheet metal. And as it relates to extra tips for sheet metal, you want to pay special attention to your flange position settings, whether it's material inside, material outside, or bend outside. And you want to pay attention to your corners where the flanges meet up, using closed corners when necessary. You want to make sure that the corners on your model match the images given in the test. Warning: this is another sample exam spoiler warning. If you've not had a chance to try the CSWP sheet metal sample exam yet, please pause this presentation and try it yourself before continuing. And then once you're done, come on back and compare your results with the sample exam I'm about ready to show. There is no older sample exams for sheet metal, weldments, surfacing, or mold tools. Alright, the next sample exam that I have to share with you is for the sheet metal CSWP, and they give you the dimensions for this part here with the variables that'll change for A, B, C, and D. And just like all the other exams, it gives you the units of measure, how many decimal places, where to put the origin, the material, the sheet metal thickness, your default bend radius, and your trim side bends option. And then here's the variables for A, B, C, and D. In question 2, A, B, C, and D. And they're wanting to know the weight of the part in grams. And then as you roll forward to check out the future changes, they're wanting you to change the K factor of the part and then find out the measured distance of X on the flat pattern. And then they want you to update the K factor again and flatten the part. And at the bottom here, of course, they give you the answers. Okay, so let me scroll up to the top again and take us over to SolidWorks to show this. So I'm going to go ahead and open that sheet metal sample. Okay, so for this part here, I'm going to go ahead and roll back to show how it was built. Have a base flange with our variables, A, B, and C. Now this one looks a little different. In fact, if I click on it, you'll notice I did not label it dim A. Instead, I'm showing the dimension names. So here it's saying A at base flange 1. When you assign a link value to a dimension, it gives it that new name identifier. And the way that you show the name of the dimension is from the view drop-down. You can show your dimension names. So that's what is happening there. Dimension names for A is for the view drop-down, dimension names. There we go. A, B, and C. And as I roll through here, we generate a cut and then add a miter flange. When you select an edge for a miter flange, it automatically generates a plane normal to the end of the edge for you. And then that miter flange is mirrored across. And by the way, to mirror that edge flange, if you planned out your initial sketch, then you can use the default mirrors in your design intent. That is when the initial base flange was produced. If you're using the mid-plane option that keeps your standard planes in the middle of the part, this is all best practice. There's no need to make an extra plane just for the mirroring. And then we can see a hole being added. And then if I needed to show the flat pattern, I could. And because I did link values, there's all my variables on question number 2. Same thing as the other exams, update your values for A through D. My note here is calling out the mass. And then for questions 3 and 4, it's the K factor that changes. So to do that, you'd go ahead and edit your sheet metal feature and adjust your K factor. And here you can see I've unsuppressed the flat pattern and I threw a reference dimension on there to find out what that distance is. Again, my link values allow me to see what my variables are. And then as we take a look at number 4, same idea. You're able to adjust your dimensions, take a look at flat pattern, and here's my reference dimension to show the distance that they're interested in. And with that, let's return to the slideshow. The Certified SolidWorks Professional Advanced Weldment Specialist. For preparation, I recommend the following training courses from DDI. The Sheet Metal and Weldments training course, as well as the Advanced Part Modeling, which is in our Advanced SolidWorks course. For webcast recommendations, you should check out SolidWorks Weldments Tips and Tricks. And for practice modeling, I recommend completing the CSWP Weldments Sample exam. And for study, you want to review your weldments as well as your advanced part modeling training books, again concentrating on the topics that are listed at solidworks.com under the certification drop-down for the CSWP weldments. And for some extra tips as it relates to weldments, you want to practice your 3D sketching. In fact, you should be comfortable using 2D sketch plane entities in a 3D sketch. And you should also be familiar with trim extend commands, including the trim order options. Warning: this is yet another sample exam spoiler warning. If you've not yet had a chance to try the CSWP weldment sample exam, please pause this presentation and try it yourself. Then come back and compare notes with me. Thank you. And now we're going to go ahead and talk about the CSWP Advanced Weldment Sample Exam. Now, these samplers are not meant to reveal all that's covered on the test. This is true for all of them. And the advice I'm giving is really just to help you save time. You still need to understand design intent and build your models in a clean and concise way. Alright, so as we scroll down here, the very first thing that's required is to build a weldment profile to use for the test. And here's dimensions A and B and the thickness with a radius. And in fact, they give you a part that you're going to download, okay, and use that structural profile that you created and follow the path that they provide. And then they give you the dimension values for A and B, and they want you to center the profile on the path. And they want to know the mass of all the weldment segments. On question number 2, they want you to build a 3D sketch, and they give you the dimensions for all the segments in the 3D sketch. In fact, they're angling some of the segments at 100 degrees. This can be tricky unless you're using your sketch planes within a 3D sketch. They're specific sketch entities. And then question 2 is asking for the length of all of your sketch segments. And then on question 3, they want you to take that same structural member that you created and populate it along the path of your 3D sketch for the top and the bottom. Paying attention to, by the way that these overlap or underlap. You'll notice they're not mitered. And they were looking for the mass of all the segments. And then we will proceed to build the vertical legs and paying attention to how the structural members butt up to one another. And here again they want the mass of all the segments. And then for the last question, they want you to change how 3 of the structural members butt up to one another, and then they want to find out the mass of just one of the segments. Okay, so as I was mentioning earlier, you should be familiar with trim order for your grouping. This is what we're talking about. And then again, they want you to measure only that segment. And one of the tips I recommend here is you can use delete body to eliminate all of the extra structural members so it does not get involved in the total mass calculation. And as I scroll down, here are the answers. And with that, let's go over to SolidWorks. Let me just scroll up to the top here. And now we'll go ahead and open the weldment sample, which, by the way, I would point out, since they're having you generate a structural member profile, you're going to want to do that based on the values that they're giving you. And in order to save your structural member, of course, as you know, you need to highlight your sketch, do File, Save As, and save it as a library feature part. Now the trick is the folder structure for this, so when I save this out as a library feature part, I need to have a file location where I'm storing my profiles along with a subfolder for my standard and a subfolder for type. And then this structural member cross-section will be the sizes that show up in the dialog. Basically what I'm talking about here is as I go to open my first part, okay, in order to use that cross-section there for my structural member feature, I need to give it which standard and what type. Now the way that you set that up is again under your tools options for your file locations for your weldment profiles. Okay, and you're going to need to add your location, which I have picked out here for my sample exam, my sample profiles, and this is the sort of thing that you should have set up before you go to take the exam. Okay, so now after I add this, I should be able to go into my structural member and from the standard drop down be able to find my CSWP standard, my CSWP type, and then there's my size. Okay, and then from there I can tell the mass of my part. Now question number 2 was more tricky because that dealt in 3D sketches, Now when you're generating your 3D sketch, I would point out that you have available to you these sketch planes. They're different than your reference geometry planes because these actually exist in the 3D sketch. Okay, and as I double click on one of these planes, you can see it became active, and then these are the sketch entities that belong on that plane. Okay, so you're going to need to investigate how to do this, but when done properly, you can make these planes based upon those sketch entities, and that's how you get the 100-degree angle in there, okay, for those line segments. And in order to find out the total length of all of these line segments, you should be able to just rectangular select them, and then under Evaluate, go to Measure. And it's picking up that plane. There we go. There's the total length of all of my segments, 13,924 and change. Alright, and then for the third example here, using that same 3D sketch, we want to take our structural members using the same profile and choose the top and bottom paths, paying attention to the corner treatments, right? And if you need to override that specific corner, you can do that. And again, they were looking for the total mass. The next one here was adding in the vertical legs. Again, looking for total mass. And then finally, they were changing up the way that that corner intersects. So if I edit that structural member, in this corner you have corner trim order. This is where you can change how these butt up with one another. Can trim order number 2 in this example is the one that works. Then you of course hit next for each group to get to the next corner. And then in order to find the mass of just one of these segments, as you go to Mass Properties, you can clear this selection and then pick only that structural member and then recalculate, and it gives you the mass of just that one item. Or one of my tips is if you want to make sure that it's going to give you only that body, you can always use Insert, Feature, Delete Body and basically eliminate all the other structural members that you're not interested in at the moment. And now when you do Mass Properties, of course, it's going to give you the mass of the only thing that's left. And with that, let's get back to the slideshow. The Certified SolidWorks Professional Advanced Surfacing Specialist. For this exam, I recommend the following training course from DDI, Surface Modeling. And for webcast recommendations, please check out from ddicad.com from the training drop-down under webcasts or SolidWorks Surface Modeling. And for practice modeling, please complete the CSWP Surfacing Sample exam. And for study, you should review your surfacing book, concentrating once again on the topics that are listed at solidworks.com. From the support drop-down under certification, click on the CSWP Surfacing. I would also recommend checking out 3dcontentcentral.com and downloading the model SCoobyWorks made by Mike J. Wilson and taking the rollback bar to walk through the model to see how he created it, keeping in mind that you can stop at each step and edit the feature to see how it was generated. And for extra tips as it relates to surfacing, you want to be comfortable with your trim and extend, untrim, and knit surface commands. And for extra study, you can check out Matt Lombard's SolidWorks Surfacing Bible. Warning! This is another sample exam spoiler warning. If you're interested in taking the CSWP surfacing exam and you have not yet had a chance to attempt the sample on your own, please pause this presentation to attempt it yourself. And then when you're done, come on back and we can compare notes. Thank you. And now to talk about the CSWP surfacing sample exam. So this PDF here is the one that you can download, and they're basically saying that you're going to build the shape of a mouse, and the file that they have you download has a sketch picture, and basically it has the sketch picture in this top surface here, and they want you to recreate this surface here, the green surface. And they give you some specific rules for the surface to follow, as well as an angle. and it should basically follow the sketch picture. And they want to know the total surface area of the newly created face. Question number 2, they have you generate a fillet between those faces, and then they want to know the surface area of the fillet. For question number 3, they want you to trim off the nose of the mouse, and they want the surface area of the top surface. And then for question 4, you're going to mirror it across and then solidify it, and then apply the material of ABS to the part, and then give the resulting mass. And then of course they give you the answers. Now here they're telling you the tolerance on the answers, and this is true for the exam. There's a tolerance on the answers. After all, you are using a sketch picture, so that makes it somewhat up to interpretation. After all, you'll be drawing some splines to map the sketch picture. Bring it to the top here, and we'll go into SolidWorks to take a look at this. Okay, so over here in SolidWorks, let's go ahead and open the surfacing exam. So surfacing sample number 1. And let me roll back here. Basically, this is what they provide you with, this top surface and this sketch picture. And your job is to generate a surface in this area with the rules outlined on the PDF. Now, I chose to do a filled surface here, so I generated my first sketch with the angle that was given, and then a second surface with my spline, which, by the way, one of the tricks with splines is to minimize the amount of points that you add and instead use the handles to shape your spline. If you have a bunch of points, you're going to introduce error into your final surface. So I'm going to go ahead and cancel that. And then once I've created the boundaries for my surface, I chose to do a filled surface, and forcing it to be tangent to the two faces that I created and only in contact with the original surface they gave me. And here we said we're looking for the surface area of only that face there, so I can go ahead and measure that and find the surface area. Now for the second question, we're supposed to take that same model and add a fillet. So in order to fillet it, of course, you can't fillet between two surface bodies. You need to knit them together first. And then you have the ability to fillet it. And then you just select on the fillet, into your measure to find the area. And then for the third question, you go in there and add a surface trim. So here's how they wanted the front to be cut off. So I applied a surface trim, removing that portion there. And then we want to find out the total surface area here. So you go ahead and use your measure and you figure out what that surface area is going to be. And with that, let's get back to the slideshow. The Certified SolidWorks Professional Advanced Mold Tools Specialist. For this exam, I recommend Digital Dimensions Mold Design Using SolidWorks course, and you could benefit from the surface modeling class. My webcast recommendations for the exam is Mold Making in SolidWorks and SolidWorks Surface Modeling. And for study, you should review your mold design and surface modeling training books, concentrating on the topics listed at solidworks.com from the support drop-down under certification. Then click on the CSWP mold tools. And for extra tips, you should really be comfortable using the draft analysis tool, and you should understand how to manually generate a tooling split. I mean, yes, there's automated tools to do this, but if you plan on being a mold expert, you should be comfortable doing this without the aid of the SolidWorks advanced tools. Warning, this is my last sample exam spoiler warning. If you're interested in taking the CSWP Mold Tools Specialist exam and you have not yet had a chance to attempt the Mold Tools sample exam yet, please pause this presentation and attempt it yourself before continuing. And once you're done, come on back and we can compare notes and see how you did. Thank you. And finally, for our last sample here, the CSWP Advanced Mold Tools. Again, they give a lot of the same advice. And the exam will cover some of the following areas: parting line creation, imported part repair, shut-off face creation, and using the draft analysis tool. So on the first problem, they give you this imported part, and they want you to create the tooling split and find out how much the cavity side of the tooling weighs. And here are your variables, A, B, C, and D. Now, on this particular test, as we take a look at problem number 2, you'll notice that they're not using the tooling split here, but what they are wanting to know is how many negative faces that part has. And then the last question on this exam was to generate your shutoff surfaces and then to get the total surface area of the shutoff surfaces. And then, of course, the answers are here on the last page. So let's go over into SolidWorks to show this. And over here in SolidWorks, let's go ahead and open the Mold Tools sample. So on sample number 1, as I roll back here, here's the part. First thing you want to do is show your mold tools, of course. And then with your mold tools, you'd want to drop in your parting line. Then drop in your parting surface. And then generate your tooling split. And they were looking just for the cavity block, so I used the body delete to eliminate the part and the core so I could figure out the mass of just the cavity. And for question number 2, we want to find out how many negative faces are on here. So the parting line separates the positive from the negative faces, so when that's done, I can then check my draft analysis on my evaluate toolbar. And with face classification, I can find out how many negative faces that I have, or negative draft faces rather. And then finally, question number 3, they have you open a different imported part and generate your shutoff surfaces. And then using that good old body delete trick, we can get rid of the solid. And from here you can use your measure and find out the total surface area of all of those faces. And that's all there is to it for using the mold tools on this CSWP Advanced Mold Tools Specialist sample. And with that, let's get back into the slideshow to finish out this presentation. The Certified SolidWorks Expert. At this point in your SolidWorks certification journey, if you've managed to meet the prerequisites to qualify to take the Certified SolidWorks Expert, then that means that you have prepared well enough to pass the Certified SolidWorks Professional and at least 3 of the 5 advanced CSWP topics. Those topics ranging from sheet metal weldments, surfacing, mold tools, and simulation. So by now, you've mastered design intent, and you fully understand how to document your model well enough to make quick changes. At this point, my best advice is to practice troubleshooting. Start breaking models and fixing them, all while timing yourself. Perhaps take a model with a specific design intent in one direction and intentionally deciding to go in a different direction with it. In other words, go back to the foundation of a model, make fundamental changes to it, but yet still be able to roll forward and have it update correctly. Again, keeping in mind the amount of time it takes you to do this. The Certified SolidWorks Expert exam may feature some or all of the hands-on challenges in these areas. And again, this is the same list that's available from SolidWorks.com from the support drop-down under certification when you click on the Certified SolidWorks Expert. Challenges include lofts and sweeps, in-context assembly design changes, imported part modifications, belts and chains, both with respect to the assembly belt chain command as well as belts and chains in sketches using sketch blocks, multi-body parts having the ability to move copy bodies around, perhaps using your Boolean operations to add, subtract, and common volume, as well as the use of sketch pictures and the ability to model springs, as well as great familiarity with the split tool. If you still want to prepare for the expert, then I recommend going through our webcasts, again, those being design planning and communication using SolidWorks, as well as reviewing your training books from your SolidWorks training classes. I wish you all good luck at becoming certified SolidWorks experts. My certification final thoughts. Learning design intent, as well as mastering some modeling tips and tricks for the express purpose of passing the certification exam, really defeats the purpose and integrity of the certification tests. This advice also represents SolidWorks best practices that you should be using on a daily basis in your own design work. So, after you become certified, it is your responsibility to practice parametric design, as well as to help others learn and understand design intent, thereby continuing to hone your own design intent skills. Keep in mind that your learning should never stop. Even after you become certified, there's always more to learn, relearn, or discover. So keep practicing. All of the images that have appeared in my SolidWorks webcast represent SolidWorks customers, a few of which are DDI customers. They are Fender Guitars, NOAO, and Triaxial Design and Analysis. All of us here at DDI are trying to reach out to you. Please follow us on Twitter or check out our Facebook fan page. You can find us on YouTube, or you can listen to our weekly podcast, SolidWorks Heard, or you can join our microblog. Thanks again for joining me on another DDI Productivity webcast. My name is Joseph Richter, and good luck.